Hello everyone. We are going to start our new unit, which is our last unit of the year, called Systems of Equations. And what I hope to do is introduce the idea of what a system of equation is and how to work with it. So let's read the objective at top. It says, to understand what a system of equations is, and what a solution to a system of equations is. That is our objective. Also, to know when a system of equations is needed to solve a problem. So if you want to, you can take a moment to print this note guide out if you would like, or work out these problems on a separate piece of paper if you want. But either way, we're going to want these notes for our quizzes and tests. So if you want to pause the video here and take a moment to print it out, you can find the file in Canvas. All right, let's go ahead and start by looking at our first problem. It says, I'm thinking of two numbers. I'm thinking of two numbers right now, and I have two numbers that I'm thinking of. See if you can figure out what the two numbers are. So here's clue number one. The two numbers add up to 9. So think of some possible solutions of two numbers that would add up to 9. And hopefully you're thinking that there are actually more than one set of numbers that add up to 9. So maybe the most common answers I think I would see would be 4 and 5 add up to 9, or maybe 1 and 8 add up to 9. And notice also how I'm writing these two numbers. I'm writing them as an ordered pair. So also 0 and 9. 0 and 9 also add up to 9. And so we could come up with a whole list of numbers that add up to 9. 3 and 6 add up to 9. And don't forget negatives. -1 and 10 also add up to 9. So we can come up with a bunch of numbers if we want, but to know the real answer of the two numbers I'm thinking of, because remember, I'm thinking of two numbers, you would need a second clue. So here's clue number 2. If you subtract one number from the other, you get 5. So think about it. If you take one number and subtract it from the other, you get 5. So would 4 minus 5, if you subtract those, you get 5? No. 1 minus 8 give you 5? No. 0 and 9 give you 5 if you subtract them? No. So none of these here give me 5 when you subtract them. So you'd have to think of a pair of numbers that have a difference of 5. So think about, let's see, possible solutions to this question. Well, 9 minus 4 gives me 5. Do those add up to 9? No. What else subtracts to 5? I guess 10 and 5. Do those add up to 9? No, it seems like they would have to be smaller. Let's see. 5 and 0 subtract to 5. Do those add up to 9? Because remember, we also want to add up to 9. Those don't add up to 9. So take a moment to think about this, because we haven't come up with our answer of these. Hopefully after some thinking, we get to the pair 7 minus 2. Think about what 7 minus 2 is. Does 7 minus 2 subtract to 5? It sure does. Does 7 and 2 add up to 9? It sure does. So what happens is 7 and 2 were the two numbers that I was thinking of. And that has to be the answer because it satisfies both clues. 7 plus 2 equals 9, that's clue number 1, and 7 minus 2 equals 5, which was clue number 2. So what we just looked at was a system of equations problem, where we had one bit of information, which was called clue number 1, and then we have a second bit of information called clue number 2. And with those two combined, we came up with one answer. Now, each of those clues technically have an infinite amount of answers. We could have kept going with clue number 1, and we could have kept going with the list for clue number 2. But the answer to the question is 7, 2 because it satisfied both clues. Let's just try one more. So clue number 1 in this case is going to be if you double one number and then add the other, you get 11. So if you double one number and then add the other, you get 11. I'll give you a moment, maybe pause the video to think about some options of doubling a number, adding something else to get 11. So some options that I thought about were, if I double 5, I get 10, and if I add 1 to 10, I get 11. So that would be a possible solution. 2 times 5 is 10, plus 1 more would be 11. So I'm doubling one number and then adding this other one to get 11. So 5 comma 1 would be a solution. Let's see, what happens if I double 4? 2 times 4 would be 8. What would I have to add to 8 to get 11? 3. So 4 comma 3 would be a solution to that, because if I double 4 and then add 3, I get 11. Well, if I double 3, I get 6, and 6 plus 5 is 11. So if I double 3 and then add 5, I get 11. So all of these are solutions to this. Also, recognize that you can double 6, which is too much. If you double 6, it's 12. So I'd have to subtract 1 or minus 1 from 12 to get 11. So that's also a solution. So that is clue number 1. And the next question is, how can you represent this algebraically? Well, notice we're doubling the first number, and the first number is in our x position. So we can say 2 times x is a doubling of a number, and then adding the other. So adding the other number was the y value. If I add 2x plus y, I get, or equals, 11. So that is the equation expression, or the equation that represents that clue. So let's look at our second clue. Clue number 2 is saying these two numbers add up to 8. So let's come up with a list of numbers that add up to 8. Well, 0 and 8 add up to 8, and 1 and 7 add up to 8, and 2 and 6 add up to 8, and 3 and 5 add up to 8. And I'm noticing something right here. Notice 3, 5 is our solution for clue number 2, and 3, 5 is also a solution in clue number 1. Well, that's actually our answer. The two numbers I'm thinking of for clue 1 and clue 2 has to be 3 comma 5, because it's a solution to both clues. So how do you represent that second clue algebraically? Well, if you add the two numbers x plus y, you get 8 is the solution to that. So what we're going to do is we're going to take those two equations right here, and we're going to take our answers and show how to check to make sure that 3 comma 5 is a solution for the second problem. We're going to go and look algebraically how we knew 7 comma 2 is a solution to the problem. So both of those equations are written out here. Notice this is clue number 1 for the first problem. It says two numbers that add up to 9. Let me go back up here so you could see that. That was clue number 1, two numbers that add up to 9. And then the second clue was, if you subtract the two numbers, you get 5. So that's x minus y equals 5. Where was clue number 2? Right there. If you subtract one from the other, you get 5. So what we're looking at right here are two equations. This right here is called a system of equations. And a system of equations is just more than one equation. A system of equations is more than one equation. And the answer to a system is like the answer to these clues. We're trying to figure out the one coordinate point, or the one set of numbers that satisfies both clue number 1 and clue number 2, which in the same way, we're looking for the x and the y that satisfies both of those equations. So how do we test again algebraically if it's a solution to this system? Well, look at the first solution we came up. We came up with 7 comma 2. So what we're going to do is we are going to check 7 comma 2. Let me write it off to the side over here. We're going to check 7 comma 2. Now, how do we know that point is actually the solution to this system? Well, what we have to do is remind ourselves that 7 represents the x value in a point, and 2 represents the y value of the point, and we have x's and y's in our equation. So we can substitute 7 in for x and substitute 2 in for y. In other words, plug those in to see if it satisfies the equation. Well, let's go ahead and do that to equation number 1. So here's equation number 1. is x plus y equals 9. Well, if we substitute 7 in for x, the 7 is going to go there. And then if we add the y value, which is 2, the 2 would go there. And we're going to check to see if that is true. Is it true? Is 7 plus 2 equal to 9? That is true. This ends up being 9 equal to 9 if we simplify it. So this point right here satisfies the first equation. So let's go ahead and check to see if it satisfies the second equation, equation number 2, which is x minus y equals 5. Now, we're going to do the same thing. We're going to substitute 7 in for x, so 7 is going to go there, minus, and then 2 in for y, so 2 is going to go in right here. And we're going to simplify. On the left side, we have 7 minus 2, which is 5. And we get the equation 5 equals 5, which is a true statement. So if you get a true statement for both of your questions, or both of your equations, then we have confirmed that 7, 2 is a solution to that system of equations. And here's the work to prove it. So anytime you want to check to see if a coordinate point is a solution, you just plug that point into both equations to see if it ends up being true. Okay, now let's look at example 2. What was our solution for example 2? It was 3, 5 for both of those clues. So we are going to check 3, 5. So let's write that over here. Let's check 3, 5. So let's start with equation number 1. Equation number 1 says 2 times the x value, and the x value here is 3. I'm looking at my point over here. The x value is 3. So 2 times 3 plus y, and the y value is 5. So I'm going to put 5 where the y would be, and then equals 11. So I just copied the first equation and put 3 in for x, 5 in for y. Then I need to simplify it. So let's simplify this. 2 times 3 is 6. So 6 plus 5 equals 11. It's going to rewrite the equation step by step. Then I have 6 plus 5, which is 11. So I get some equation that is true. So it checks out for equation number 1. And so what we'll do is we'll do the same thing for equation number 2. Equation number 2 says x plus y equals 8. Well, x is 3, so I'll say instead of x plus y, 3 plus 5, because that's what the x and the y are. So x plus y, or 3 plus 5, equals 8. And we're going to simplify that. So if I simplify 3 plus 8, I get, or I'm sorry, if I simplify 3 plus 5, I get 8. So 8 equals 8, and that is a true statement. If both of them turn out to be true, then that tells me that 3, 5 is a solution. So we saw 2 examples here where it turned out to be a solution. Well, what would happen if it wasn't a solution? What would happen in the work? Well, you can take any of these, like for example, you can take the coordinate point 0, 8. If we checked 0, 8 in one of these equations, like if we put 0 in for x, 8 in for y, notice it does not end up being true. So 2 times 0 is 0, and 0 plus 8 is not equal to 11. So this is not, 0, 8 is not a solution, and that's how we check and know something is not a solution, if the equation doesn't work out for both of them. So best of luck on your homework. You have assignment 5.1a, and you can get that homework assignment from Canvas.